Welcome, everyone. Over the next 20 minutes, we will begin a critical exploration of one of the most significant operational and strategic shifts in modern finance. This isn't just a story about technology, it's about an invisible war for the integrity of the global financial system. We'll start by understanding the battlefield, why the old ways of detecting fraud and money laundering broke down, and why a revolution was not just beneficial, but absolutely necessary.
Let's begin with a scenario that defines the new era of threats. In February 2024, Hong Kong, a finance worker at a multinational firm receives a video call. On the screen is the company's CFO. The face, the voice, the mannerisms are flawless. The instruction is clear and urgent. Authorize a secret, time-sensitive transfer of $25 million. The CFO was a deepfake, a hyper-realistic digital forgery generated by artificial intelligence. The money vanished into the digital ether. This was not a test or a theoretical exercise. It was a real crime, and it underscores a fundamental shift. Criminals now wield powerful AI tools. This is the front line of financial crime today. It's a war measured in milliseconds and billions of dollars, where the adversaries are no longer just individuals but sophisticated algorithms. To understand how to fight this situation, we must first understand why the old defenses became obsolete. For decades, the backbone of financial crime detection was the rule-based system. The logic was straightforward, almost arithmetic. If a transaction exceeds $10,000, then flag it for review. If there are 5 failed login attempts in 10 minutes, then lock the account. If a purchase originates from a country the customer has never visited, then decline it. Imagine the physical manifestation of this approach. A rulebook that grew thicker with every new scam, every regulatory requirement, every loophole discovered. Analysts were buried under mountains of automated alerts. And here lies the central catastrophic flaw, the staggering inefficiency of these systems. Industry studies consistently showed that 90 to 95% of all alerts generated were false positives, perfectly legitimate transactions mistaken for crime. Let's quantify that operational nightmare. At one major European bank, analysts faced approximately 1,200 alerts every single day. Of these, 99.5% were unrelated to actual fraud. Think about the resource drain. Highly skilled investigators spend the majority of their time chasing ghosts, sifting through endless noise. This creates a dangerous vulnerability window. While your team is occupied verifying a customer's vacation spending, a sophisticated criminal network is moving illicit funds through a gap in the digital fence. Criminals are keenly aware of these rigid rules and have become experts at smurfing, or structuring, the practice of deliberately breaking down large sums of money into smaller sub-threshold transactions to avoid detection. A $100,000 illegal transfer becomes 10 transactions of $9,999, flowing through different channels, effectively becoming invisible to the rulebook. The impact isn't just internal. The customer experience suffers profoundly. How many times has a legitimate card been declined at a hotel abroad because the location was unusual? Or a large one-time purchase for a home appliance been blocked because it was out of pattern? The system lacks context. It doesn't know you're on your honeymoon or finally buying that new refrigerator. It only knows the rules, leading to frustration, embarrassment, and eroded trust. Finally, the traditional model was cripplingly slow. Analysis could take days or weeks. By the time a human investigator connected the dots on a suspicious pattern, the money trail was cold. The funds would have already circulated through a labyrinth of shell companies across multiple jurisdictions, successfully laundered and integrated into the legitimate economy. The system was reactive, cumbersome, and losing the battle. This was the untenable reality for the financial industry. A perfect storm of sophisticated AI-driven attacks, internally swamped operations, frustrated customers, and regulatory pressure. The rulebook was not just outdated, it was a liability. The stage was set for a fundamental transformation, a move from rules-based logic to intelligence-based learning. This shift from asking, "Does this break a rule?" to "Does this make sense?" is the core of the revolution we'll explore next. To summarize, the why is clear. The old paradigm of static rules collapsed under the weight of its own inefficiency and was outpaced by adaptive criminal innovation. The cost was measured in lost funds, wasted resources, and customer dissatisfaction. In our next module, we will transition from the problem to the solution. We will dissect the how, the artificial intelligence technologies that learn, reason, and predict, and we will examine real-world case studies proving their transformative power. Consider this question as you prepare. If a system could learn the normal behavioral rhythm of every customer, how would that change the very nature of detection? Welcome back. Having established the critical failures of the past, we now turn to the intelligent engines powering the future of financial security. In this module, we will move beyond buzzwords to understand the core mechanics of the AI tools in use today. We will then validate this theory with concrete, quantifiable results from leading global institutions. This is where we see the strategic vision become operational reality. Artificial intelligence in this context is not about sentient machines. It's about advanced adaptive pattern recognition. The core technology is machine learning, particularly through artificial neural networks. Think of the difference between teaching someone to identify a cat. The old rule-based method would be a manual. If it has 4 legs, fur, pointed ears, and whiskers, it's a cat. This fails when you encounter a hairless sphinx or a lynx. A neural network, however, learns like a child. You show it millions of images labeled cat and not cat. It self-discovers the complex, often non-verbalizable patterns, the proportions, the texture gradients, the contextual cues that define catness. It develops an intuitive model. This is precisely how AI fraud detection works. Instead of images, it ingests millions of transactions, learning the subtle patterns of legitimate activity versus fraudulent activity. The first powerful application is behavioral profiling. Traditional systems see a customer as a list of static data points like name, account number, and address. AI builds a dynamic, living profile of behavior. It learns that you typically log in from New York at 8 a.m., buy coffee with your mobile wallet, make larger electronic payments on the first of the month, and travel to London for work twice a quarter. It establishes your unique financial rhythm. Therefore, when a login attempt originates from a new device in Romania at 3 a.m., followed immediately by an attempt to transfer funds to a high-risk cryptocurrency exchange, the AI doesn't need a rule against transfers to crypto exchanges. It recognizes a severe anomaly in the behavioral pattern and can flag it in milliseconds. The second, even more powerful weapon is graph analytics. Traditional systems examine transactions in isolation. Transaction A, then B, then C. Graph AI maps relationships. It creates a vast interconnected web, a social network for money. Every account is a node. Every transfer, shared IP address, common device fingerprint, or overlapping beneficiary is a connecting line. Criminal money laundering relies on complexity to obscure origins. Funds move from account 1 fraudulent to shell company A to shell company B in another country to a seemingly legitimate business, and finally into a clean account. Viewed in isolation by a human, each step might appear justifiable. But Graph AI visualizes the entire hidden network. It can identify clusters of accounts with opaque ownership, unusual circular flows of funds, or nodes that act as central connectors for otherwise disparate entities. It sees the forest, not just the individual trees. Now, let's see this theory in action with 3 landmark case studies. Case Study 1, HSBC. The efficiency breakthrough. HSBC, with $3 trillion in assets, was drowning in false alerts. Their partnership with Google Cloud aimed to build a global anti-money laundering AI. The system processes 1.35 billion transactions monthly using neural networks trained on HSBC's own historical data. The results were transformative. Effectiveness. It detected 2 to 4 times more genuinely suspicious activity. Efficiency. Total alert volume dropped by 60%. This is the pivotal win, finding more crime with far less noise. Network detection. It excelled at uncovering complex laundering networks via graph analytics, linking coordinated accounts and shell companies invisible to rule-based screens. This is AI as a force multiplier, enabling investigators to focus on genuine threats. Case Study 2. MasterCard, the predictive edge. MasterCard tackled a specific nightmare. stolen credit card details sold on the dark web with only partial numbers visible. Their innovation combined generative AI and graph technology. The generative AI takes the partial number and generates probabilistic models of the full 16-digit number. The graph system then analyzes the entire network. Have any of these potential cards been used at merchants linked to previous breaches? Are they showing pre-fraud patterns? The outcome was a 300% improvement in fraud detection. Critically, they identified compromised cards before they were used fraudulently, shifting from reaction to prediction. This also reduced false declines for legitimate customers by 22%. Case Study 3. PayPal, the behavioral shield. PayPal's challenge is social engineering scams, where users are manipulated via romance scams or phishing into willingly sending money. Traditional systems fail because the transaction is technically authorized. PayPal's AI analyzes over 500 behavioral data points in real time: typing speed, mouse movements, typical payment recipients, even the linguistic patterns in communication fields. It builds a psychological and behavioral baseline to detect signs of manipulation. If a user who normally sends small, irregular amounts to friends suddenly starts sending large, escalating sums to a new contact, the AI can intervene with a dynamic warning. This system blocks over $500 million in fraud quarterly, protecting both money and customer trust. These cases demonstrate that AI is not a monolithic solution, but a toolkit. HSBC shows its power for operational efficiency and network detection in AML. Mastercard illustrates predictive, network-based defense for fraud. PayPal reveals its depth in understanding human behavior and intent. The common thread is a move from simple binary rules to complex, contextual, and continuous learning. In our final module, we will look ahead. As powerful as these tools are, the arms race accelerates. What new threats emerge, and what ethical and regulatory frontiers must we navigate to ensure this powerful technology is used responsibly?
Welcome to our final module. We have seen the problem and the current AI-powered solutions. However, in a domain defined by adaptation and counter-adaptation, standing still means falling behind. This session focuses on the horizon, the evolving threats, the next wave of defensive technologies, and the crucial framework of ethics and regulation that must guide their deployment. The future of financial security is not a fixed destination, but a continuous journey.
We began with a $25 million deepfake heist. That was a warning shot. The uncomfortable reality is that criminals have access to the same foundational AI technologies. This is the era of adversarial AI. In 2025, a small but rapidly growing percentage of fake documents presented to banks were generated by large language models like ChatGPT. The FBI warns of autonomous AI agents that can execute complex fraud schemes from card testing to synthetic identity creation, with minimal human intervention. Forecasts predict AI-driven fraud losses could skyrocket from $12.3 billion in 2023 to $40 billion by 2027. The battlefield is now algorithmic: offense versus defense, each probing the other's weaknesses. In response, defensive AI is evolving into more nuanced realms. Behavioral biometrics moves beyond what you know or what you have to analyze how you behave. It studies your unique typing cadence, the micro movements of your mouse, even how you scroll. This neurobiological signature is incredibly difficult to mimic. Even with stolen credentials, a bot's interaction pattern will differ from a human user's, triggering an alert. Voice biometrics is advancing to combat deepfake audio. While synthetic voices are impressive, they often lack subtle, subconscious micro-patterns of human speech, certain breath sounds, emotional harmonics, or inconsistencies in spectral features. Advanced AI detectors are trained to find these digital uncanny valley artifacts. Looking further ahead, quantum computing looms as both a monumental threat and a revolutionary tool. On one hand, quantum machines could break current public key encryption, jeopardizing all digital security. Banks are already investing in quantum-resistant cryptography. On the other hand, quantum machine learning offers staggering potential. A bank like Italy's Intesa Sanpaolo is experimenting with quantum algorithms for fraud detection. quantum computers can evaluate countless transaction pathways simultaneously, potentially identifying ultra-complex fraud patterns imperceptible to classical computers. Governments are investing heavily, with the UK committing over $160 million to quantum tech for fighting financial crime. As technology advances, so do the ethical and regulatory imperatives. Modern AI, particularly deep neural networks, can be a black box. We see the input and the output, but the internal decision-making process is opaque. This is unacceptable in regulated finance. Regulations are emerging to mandate explainable AI. The EU's AI Act classifies financial AI as high risk, requiring transparency and human oversight. Regulators demand to know, can you explain why the AI declined this transaction? Can you prove it isn't discriminating against a demographic group? The RegTech market is booming precisely to help institutions meet these compliance challenges, ensuring AI is not only powerful, but also fair and accountable. Furthermore, crime is global, but data privacy laws like GDPR are territorial. How can banks collaborate to fight cross-border crime without illegally sharing sensitive customer data? The answer may be federated learning. In this model, the AI algorithm travels to where the data lives. It learns from the data within Bank A's secure environment, then moves to Bank B, aggregates its learnings, and so on. The model becomes collectively smarter, but the raw customer data never leaves its home institution. Initiatives like Swift's Federated Learning Sandbox are proving this model can effectively detect money laundering networks while preserving data sovereignty and privacy. Let's synthesize our journey. We began with an invisible war sparked by the failure of rigid rules. We explored the AI arsenal, neural networks that learn behavioral norms and graph analytics that map criminal ecosystems, and saw their proven impact in major institutions. Now we see the frontier, an ongoing algorithmic arms race, amplified by quantum computing and tempered by the critical needs of explainability and ethics. The conclusion is clear. Winning this war is not about deploying a single technology and declaring victory. It is about fostering a culture of continuous adaptive learning. Your institution's AI must learn from every blocked attack. Your teams must understand its capabilities and its limitations. Your strategy must balance aggressive defense with unwavering ethical commitment and regulatory compliance. The most remarkable outcome of this entire technological shift is often what doesn't happen: the fraud that never reaches a customer, the scam that is intercepted, the billion-dollar laundering network dismantled in silence. Your role is to understand, steward, and evolve these systems. The arms race has just begun. Your vigilance, expertise, and strategic foresight will determine who wins the next battle and the one after that. Thank you for your engagement in this critical training. We encourage you to discuss these concepts with your teams and consider, what is our organization's next step in this continuous journey of adaptive financial defense?